This is 4.4C, model fraction subtraction, and 4.4D, subtract fractions with common denominators. Subtracting, oh, and this is from OpenStax PreAlgebra. Subtracting fractions with common denominators is just like adding with common denominators, except you're subtracting instead of adding. And so let's look at this problem here. We have 7/12 minus 2/12 is equal to 5/12. Now we're going to go ahead and model this with our fraction circle. So I'm going to draw a circle kind of like a pizza, and I need to divide this into 12 pieces. Okay, so first I'm going to divide it into halves, and then I'm going to divide it into fourths. Now to get 12s, I can't divide each of these in half, because that's going to give me eighths. And then if I divide those in halves, it's going to give me 16ths, but I want 12ths. So if I have 4 pieces, I need to divide each of these 4 pieces into 3 pieces. So now this is a sketch, so it's not going to be exact, but we will get the right number of pieces. They won't necessarily be the right size, because I am not super great at drawing, especially on the computer. Okay, so we're going to start with 7 of these 12 pieces. So 1, 2, 3, 4, 5, 6, 7. Okay, so there's 7. Now I'm going to get rid of 2 of the 12ths because I'm subtracting 2 12ths. So I'm going to switch colors here, and I'm going to color out 2 of the 12ths. And how many am I left with after I do that of the orange ones? Well, I have 1, 2, 3, 4, 5. So I have 5 12ths left. So that's how you model fraction subtraction. Let's go ahead and do an example. Use fraction circles to find the difference. Remember, difference means subtraction. So we have 4/5 minus 1/5. So let's go ahead and draw a circle. Now we need to get this into fifths. So this is going to be a little hard. Fifths are kind of hard to sketch freehand and get them correct. It doesn't matter for this if they are the same size, as long as you get 5 pieces in there. 1, 2, 3, 4, 5 pieces. Okay, so I've got 5 pieces in there, and I'm going to start with 4/5. So I'm going to color in 4 of them. 1, 2, 3, 4, but then I want to get rid of one of them, so I'm going to color out one of them. And how many am I left with? I am left with 1, 2, 3. But I can't just put 3. I'm left with 3 what? 3/5. Okay, so try it. Use a model to find the following differences: 7/8 minus 4/8 and 5/6 minus 4/6. So go ahead and pause the video, draw out the models on your paper, and then come back. Let's start with 7/8 minus 4/8. So I'm going to draw a circle, and I'm going to divide it into eighths, which means halves, fourths, and then eighths. Okay, and I'm going to start with 7 of them. 1, 2, 3, 4, 5, 6, 7. And I'm going to get rid of 4 of them. 1, 2, 3, 4. And I am left with 1, 2, 3. I'm left with 3 of the eighths. Okay, on the next one, I'm going to draw my circle, and I'm going to start with sixths, which means I need to divide this in half, but then I can't go in half again because that would give me fourths. So I need to divide each of these halves into 3. 1, as best I can. Okay, so there's 6 pieces. I'm going to start with 5 of them. 1, 2, 3, 4, 5. And I'm going to get rid of 4 of them. 1, 2, 3, 4. And how many am I left with? I'm left with 1 of the sixths. So that's how you would model fraction subtraction. So let's talk about it without the modeling. So fraction subtraction, if A, B, and C are numbers where C does not equal 0, okay, C does not equal 0, then A, over C minus B over C is equal to A minus B over C. Okay, but C cannot equal 0 because you can't divide by 0. So what does this mean? This means subtract the numerators and place the difference over the common denominator, right? You start with C, you subtract with C as the denominator, and you end with C. The denominator does not change. Okay, when the denominators start the same, you end up with the same denominator. That's very, very, very important. You only subtract the numerators. So let's do some examples. Find the difference, 23/24 minus 14/24. So we're going to rewrite this with subtracting the numerators, 23 minus 14, and we're going to write that over the common denominator. They have the same denominator, they both have 24, so we're going to put 24 here. Now we can simplify the top. 23 minus 14 is 9. And then we leave the denominator, 9 over 24. So this is an answer, but it is not the final answer because this can be reduced. All right, we need to figure out what number goes into 9 evenly and into 24 evenly. Well, I know that 3 goes into both of those, so I'm going to see how many times does 3 go into each of these. 3 goes into 9 3 times, and 3 goes into 24 8 times. So then I can write this as the reduced fraction 3/8, and this is my answer. Okay, so make sure you subtract and then reduce. Next one, y over 6 minus 1 over 6. So I'm going to subtract the numerators, y minus 1, and write it over the common denominator, 6. Now, can this be simplified like we did up here? No, because y is a variable, it has to stay there. So this is our final solution for this one, y minus 1 divided by 6. And you would just leave it like that. Okay, now you're going to do a couple try it problems. Oops, I forgot to, when I copied this from my last one, you're going to find the differences. Okay, so go ahead and pause the video, find the differences, and then come back and see if you got them correct. So let's go ahead and work these out. First, we're going to subtract the numerators, 19 minus 7, and write it over the common denominator, which is 28. 19 minus 7 is 12 over 28. So this would be what we would get from simplifying this, but it can be reduced. So what divides evenly into 12 and into 28? Well, I know 2 divides evenly into both of those, but is there anything bigger? Yeah, 4. 4 can divide into 12 and into 28. If you didn't figure out 4, that's fine, and you just started with 2, you would go ahead and reduce and then realize you need to reduce again. Let's go ahead and do 4 though. 4 goes into 12 3 times, and 4 goes into 28 7 times. So then I am left with 3/7. So 19/28 minus 7/28 is equal to 3/7. Okay, now we have one with a variable in the numerator. So let's go ahead and do that. So we're going to subtract the numerators, x minus 2, common denominator, 7. Can this be simplified? No, it cannot. This is the solution, x minus 2 divided by 7. Okay, another couple examples. So now we have the variables in the denominator instead of in the numerator, and we have a negative. We're starting with a negative. So we do the same exact thing. Even though we've thrown in the variable in the denominator and a negative in front of the first one, we do the same exact steps. So we're going to subtract the numerators, but you got to remember that this is negative 10 minus 4. And the common denominator is x over x, okay? And this can be simplified. Negative 10 minus 4 is equal to negative 14 over x. And this is your answer. Now, here we have 3 fractions, Okay, so you're going to do the exact same thing. And so we're going to do 3 plus negative 5 minus 1 all over the common denominator. So let's go ahead and write that out. We have 3 plus negative 5 minus 1, right? All of those symbols need to go in the top. And on the bottom, all we have is the common denominator. It doesn't matter that there are 3 of them now instead of just 2 like we had before. We still just copy the common denominator. Okay, so it's 3 plus negative 5 minus 1 divided by 8. So now we're going to go ahead and simplify the top. So 3 plus negative 5. Let's go ahead and just do that one step. 3 plus negative 5 is equal to negative 2. I'm going to copy the rest of the problem, minus 1 over 8. Okay, now I can simplify this even further. Negative 2 minus 1 is equal to negative 3, and I keep the common denominator, negative 3/8, and that cannot be reduced. So that is my answer. Okay, a couple more try-its to make sure that you understand this. Go ahead and pause the video, work these out on your paper, and then come back. So let's go ahead and, once again, this should be differences. Let's go ahead and work these out. So we're going to do negative 17 minus 5. On the bottom, we keep our common denominator. The denominator stays the same. Negative 17 minus 5 is negative 22 divided by a. And this cannot be reduced because there's nothing that divides into both negative 22 and a. So that is our answer. Okay, now on the bottom with 3 fractions. Remember, you do the exact same thing that we did up here, but we do it with 3 numbers in the numerator. So we have 2 plus negative 4 minus 3. And our denominator, we have 5 as a denominator for all of those, so we put 5 on the bottom. Now we simplify. Let's simplify these first two. 2 plus negative 4 is negative 2 minus 3 all over 5, and then we can simplify this. Negative 2 minus 3 is negative 5 divided by 5. But this can be simplified, reduced even further, right? What can go divide into negative 5 and 5 evenly? Well, 5 can divide into both of those, right? 5 goes into 5 one time, negative 5, negative 1 times, and it goes into positive 5 one time. And so our solution to this one is negative 1, right? That would be negative 1 over 1, which is equal to negative 1. So that's your solution. So key things to remember: the denominator stays the same. Okay, the denominator stays the same. Later, you may need to reduce, but while you are adding or subtracting, the denominator stays the same. Please reach out to me if you have any questions. Let me know. I can send you more videos or Zoom with you, or just answer through email. Check Google Classroom for your assignment.